Hello viewers, I'm Kausalya. Today we are going to solve problems under exercise 8.1 trigonometric ratios. So the problem is if 3 cot A is equal to 4, check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A or not. Just we have to check whether this expression is true or not, right? So again the same thing, the value of cot A is given, right? So cot A is nothing but adjacent side by opposite side. So first draw a triangle and let this be your angle A, right? So adjacent side by opposite side. So this is your adjacent side and this is your opposite side. So as usual, we need to find the value of other side by using Pythagoras theorem. So when you use Pythagoras theorem, the formula will be PR square is equal to PQ square plus QR square. We know the value, so just substitute it, right? And finally, the value of PR is 5, right? Now, you see, we know all the values of, that is, we know the values of three sides. So we can easily find the value of tan A, cos A and sin A, right? So tan A is, it is nothing but it is a reciprocal of cot A, right? So if cot A is 4 by 3, then the value of tan A will be 3 by 4, right? That's it. Now the next thing is finding sin A. So sin A is opposite by hypotenuse. So from this triangle, this is your opposite side and this is your hypotenuse side. So it will be 3 by 5. It's better you can write, okay, PQ by, that is PQ by PR. Similarly cos A. So here cos A is nothing but adjacent side by hypotenuse. So here it is QR by PR, which is 4 by 5, right? Now we know all the values. So just take the expression. It is 1 minus tan square A divided by 1 plus tan square A. So now initially I have taken LHS, okay, left hand side. So 1 minus this tan square A can be written as tan A the whole square. Similarly in the denominator. So what is the value of tan A? It is 3 by 4, right? So just substitute the value. And what is the next step? You have to square. So 3 square is 9 and 4 square is 16, right? So write down the terms and the next step is you have to take LCM. So 16 minus 9 by 16 divided by here 1 into 16. So 16 plus 9 by 16. So 16 minus 9 becomes 7 by 16 here and 16 plus 9 becomes 25. Okay, the denominator part remains the same. Now when you move this denominator term to the numerator part, what happens? This appears as a reciprocal. Therefore, 7 by 16 into 16 by 25. Now these two terms cancel each other and here the answer is 7 by 25. Right. So now we are considering our right hand side. Our right hand side is cos square A minus sin square A. So this can be written as cos A the whole square minus sin A the whole square. Right. So substitute the values of cos A and sin A, right? And just square it. So 4 square is 16, 5 square is 25, 3 square is 9 and 5 square is 25, right? So finally 16 minus 9 is 7 by 25, right? Now compare both the values. You see the LHS value is also 7 by 25 and RHS value is also 7 by 25, right? Therefore, the given expression is true, okay? You can just finish it off like this. The given expression is true, right? That's it. Now we will proceed with our next problem, problem number 9. In triangle ABC, right angled at B, if tan A is equal to 1 by root 3, find the value of these two terms. Again the same thing, okay, tan A. Tan A is nothing but it is opposite side by adjacent side. So just draw a triangle, right? So here, this is our angle A. So to this angle A, what is the opposite side? This is your opposite side and this is your adjacent side. So which is nothing but BC by AB, right? So the next thing is, you see, you need sin A cos A as well as cos C sin C, right? So first consider angle A. So angle that is sine A is opposite by hypotenuse. Anyway, we need to find the value of hypotenuse side. So use your Pythagoras theorem. So AC square is nothing but AB square plus BC square, right? So substitute the values. So root 3 whole square becomes 3. So 3 plus 1 is 4. Therefore, the value of AC is square root of 4, which is equal to 2, right? So sine A is nothing but, you see, this is your angle A. So opposite by hypotenuse, that is BC by AC, which is 1 by 2. Again cos A. So cos A is nothing but adjacent by hypotenuse. So it is AB by AC, therefore it is root 3 by 2. Right. And the next thing is cos C. Now consider this angle. Right. So to this angle, cos C is nothing but it is adjacent by hypotenuse. So your adjacent side is BC and hypotenuse is AC. Therefore it is 1 by 2. Similarly, sin C is opposite by hypotenuse. So here the opposite is AB and hypotenuse is AC. So AB by AC, which is root 3 by 2. Right. We have calculated all the values. Now we have to just substitute in the expression. So the expression is, you see, sin A cos C plus cos A sin C. So what is the value of sin A? It is 1 by 2. What is the value of cos C? It is again 1 by 2 plus cos A. So cos A is root 3 by 2 into sin C is root 3 by 2. So when you solve, you see 1 by 2 into 1 by 2 becomes 1 by 4, right? 1 into 1 is 1 and 2 into 2 is 4. And here root 3 into root 3 becomes 3 and 2 into 2 becomes 4. So finally, since the denominators are same, we can add the numerators. So 1 plus 3 gives 4. Therefore, 4 by 4 becomes 1. Right. Now consider expression 2. Cos A cos C minus sin A sin C. So what is cos A? Root 3 by 2. What is cos C? 1 by 2. Right. Sin A is 1 by 2 and sin C is root 3 by 2. So again when you multiply, this becomes 1 into root 3, 2 into 2, 4. So here also root 3 by 4. So root 3 by 4 minus root 3 by 4 becomes 0. Right. So this problem gets over here. We will move with the next one. The problem is in triangle PQR, right angled at Q, PR plus QR is equal to 25 centimeters and PQ is 5 centimeter. Determine the values of sin P, cos P and tan P. Right. So here a triangle PQR is given. It is right angled at Q. Right. Therefore this angle is Q. So again the value of PQ is 5. Right. So here PQ, here it is 5. Again I am telling you can write P here and R here. Okay. It's up to you. It will never make a difference. You will get the same answer. So here PQ is 5, right? Now, what is the given thing? One side of the triangle is given and one expression is given. That's it. So, from this expression, you see PR plus QR is equal to 25, right? So, just when you rearrange, the value of PR is, when you move this QR to the right hand side, it is 25 minus QR, right? The next step is, we are going to apply Pythagoras theorem to this triangle. So when you apply Pythagoras theorem, PR square is equal to PQ square plus QR square, right? So here in this place, in the place of PR, just replace it with this equation, that is 25 minus QR. Therefore 25 minus QR the whole square is equal to, what is the value of PQ? It is 5. Therefore 5 square plus QR square, right? So this is of the format A minus B. So A minus B whole square is nothing but A square plus B square minus 2AB, right? So 25 square is 625 and this QR square as such, and 2 into 25 becomes 50, right? And this minus sign here. And here to the right hand side it is 5 square is 25 and this QR square, right? Now the next thing is I am going to shift all these equations to the left hand side. So what happens? This equation, when you move it to the left hand side, this becomes minus 25 minus QR square equal to 0. So this minus QR square and plus QR square will cancel each other. And finally you see 625 minus 25 becomes 600 and this minus 50 QR, right, equal to 0. So again, when you move this minus 50 QR to the right hand side, that becomes plus 50 QR. Therefore, the value of QR is 600 by 50, which is 12 centimeter. So here in this case, you see, they have given the dimensions, right? The value of PQ is 5 centimeter. And here PR plus QR is 25 centimeter. So that is the reason here why we are mentioning QR as 12 centimeter. Right, if ratio is given, we should not mention the units. But whenever the units are given in the question, we have to give our answers with the same unit. Right. Now the next thing is, you see, PR is equal to 25 minus QR, right? This is our equation 1 from this equation. Now we know the value of QR, so just substitute here and find the value of PR. Therefore, it is 25 minus 12, which is equal to 13 centimeter, right? So now we need to find the value of sin P, cos P, tan P. Okay. So sin P, this is your sin P, right? So what are all the values? You see, QR is, it is 12 centimeters, and PR is, it is 13 centimeter, and this is 5 centimeter. So sin P is nothing but it is opposite by hypotenuse. Therefore, that gives 12 by 13, right? So here it is 12 by 13. And what is cos P? You see, cos P is adjacent by hypotenuse. So here adjacent is this side, right? PQ by PR, which is 5 by 13. So it is 5 by 13 here. And the next thing is tan P. So tan P, it is nothing but opposite side by adjacent. So here what is your opposite side? It is 12, and what is your adjacent side? It is 5. Therefore, here the answer is 12 by 5. Right. So this problem gets over here. Finally, we are moving with our last problem of this exercise. So 11th problem. State whether the following are true or false. Justify your answer. So the first question is, the value of tan A is always less than 1. Right. So let us check. So what is the formula for tan A? It is opposite side by adjacent side. Right. So it is always less than 1. What does it mean? Then that is, the numerator value is less than denominator value. For example, you see, let the numerator be 1 and this denominator be 2. So 1 by 2, what is the ratio? What is the value? 1 by 2 is nothing but 0.5, and this is less than 1. Right. So even if it becomes, that is, even for 3 by 4 also, it will be 0.75 less than 1. That is, the only condition is, if the numerator is less than the denominator, then the value will be less than 1. But there are some cases where the numerator is greater than, that is, the opposite side is greater than the adjacent side. There are cases. So we cannot tell. You see here the question is, the value of tan A is always less than 1. No, it is not always less than 1. It is sometimes less than 1, and it is sometimes greater than 1. Right. Therefore, the given statement is false. Right. Now, the next thing is, secant A is 12 by 15 for some value of angle A. That is secant A. So, secant A, it is nothing but, it is the reciprocal of cos A. Right. So, secant A is hypotenuse by adjacent side. So, here it is 12 by 5. Right. So, as we all know, you see, in a triangle, what is your lengthiest side? Hypotenuse is your lengthiest side. So this side always holds the bigger value or bigger number. So here in this case, you see, hypotenuse is 12. Okay, let this angle be, that is, let the angle A be here. So 12, and this is your adjacent side. Is this possible? Yes, it is possible, because the hypotenuse is given with a bigger number and adjacent side is given with some smaller number. Right. So therefore, it is true. Yeah, we can have secant A value as 12 by 5. Right. So the next one is, cos A is the abbreviation used for the cosecant of angle A. Right. So as we all know, cos A. So when you take reciprocal of cos A, what is that? You see, the normal method is sin, cos, tan, then cosecant, secant and cot. Right. So, cos A is the abbreviation. Cos A is the abbreviation used for the cosecant of A. No. Cos A is nothing but it is cosine of A. Right? Not cosecant of A. So, cosine and cosecant are totally different. Right? So, it is false. And the fourth one is cot A is the product of cot and A. No, whenever you split cot A as cot and A, it doesn't hold any meaning in max, right? Therefore, it is false. And finally, sin theta is equal to 4 by 3 for some angle theta. So, sin theta is opposite side by hypotenuse. So, when you look at this ratio, you see opposite side is greater than the hypotenuse value. So, this is not possible because as we all know, hypotenuse is the lengthiest part. Therefore, this statement is false, right? So, here comes the end of your exercise 8.1, right? If you have any doubt in this video, let me know in the comment section. Thank you.